Hello, hello there. Welcome back in another video. So in here, then we'll begin to work on with the adjacency matrix for unweighted directed graph. So earlier, we're able to illustrate the undirected graph. However, right now, this is actually dealing with directed graph. When we say directed graph, there is a direction pertains to these structures. So how can we work on with the adjacency for unweighted graph? The same representations that you will begin to work on with the rows and column. So since that we do have here M, N, O, P, Q, R, S, T, I don't know, S only. And then M, N, O, P, Q, R, and S. How can we work on with this one? You have to check if there will be adjacent. For getting the adjacent plus, make sure that this is actually, for example, this is your I and this is your J. We will begin to mark as one if I is equals to J. And then that is we'll begin to deal with the arrow. Actually, where does the arrow points out? So if the arrow if from M or from I pointing to J, so therefore is adjacent to J. However, J is not adjacent to I. That's how you will begin to interpret that because this is actually a one-directional model here or representation, and you will not begin to follow in terms of you will not begin to follow in terms of the undirected graph that they are bidirectional, meaning that the I is equals to J and J is equals to I, definitely. So right now, for example, M is to M, that is 0. Then M to N, that is 1 because they do have adjacency. Then M to O, they are adjacent to each other, that is 1. Then M to P, that is not adjacent. M to Q, that is not adjacent. Then M to R, they are not adjacent. And M to S, they are not adjacent. That's how it works. Now let me just go ahead and put a label here then so that I'll begin to just put a boundary in order for us to work on this carefully, okay? Now after that one, you have to work on with the N. N to M that is not adjacent because that is not bidirectional. And then N to N they that is not adjacent. N to O they are adjacent, so that is one. Then N to P that is not adjacent because the arrow is coming from P to N. So it's not out order, that is actually dealing with in order. Now, in terms of Q, right now, N to Q, that is still 0, and R, that is 0, and S is 0. Now, for O, O actually goes to S, goes to Q, and goes to P. So we can update OS, OQ, and OP. So OS 1, OQ 1, and O P1. So therefore the rest will be marked as 0. What about for P? P is actually pointing to N alone. So therefore M going only to N. So therefore I mean P going to N. So that is the only adjacent here. So we can just mark that as check and the rest will be marked as 0. Then afterwards, for the Q, that is actually adjacent to P alone. So therefore, it will be 1 Q to P, then the rest will be zeroed out. Okay. Now afterwards, for R, is actually adjacent to P alone. So R to P, that will be marked as 1. So the rest will be still 0. And then for your S, where is it adjacent? As actually, there's no, I'm so sorry. In terms of this one, we do have, um, another set of, there will be two S. So what we can do, let's just change this into T. Okay, T. All right. So what will gonna happen for this one? We have to update. Okay, let me update this first. Okay. Now, T, and then here M, N, O, P, Q, R, S, then T. So therefore, here then for the S that is adjacent to Q alone, so S to Q will be marked as 1, so the rest will be 0, 0. Okay. Now, here then you have to mark everything as 0, and then there will be additional um flow here. So for T, it will be marked as 0 still because there's no connection going to T. Okay. Now, in terms of letter T, T is actually connected to Q. TQ is 1. TS is 1. P is 1. Then TR is 1. So therefore, that's the only direction for from T. So the rest will become zeroed out. So regardless of what will gonna happen, class, if you will begin to work on with this, if you will begin um to what do you call this one, you will begin to convert this into column. Say for example that this first row you'll convert it into column, it will become 0 1 1, then there will be 4 0, and then afterwards the second row will become second column 0 0 1, then 0 the rest, and then afterwards here it will become 0 0 0, and then 1 1 0 1. That's how it worked. Sorry, 0 0 0 3 zeros, 2 0 1 0 1 0. What about above 0 1 1? Then 5 zeros. What about the second 0 1, and then the rest will be 0. And then for P, here it will become 0 1, then the rest will be 0. And then afterwards, here will become 0 0 0 1. The rest will be 0. And afterwards, here, the same thing, 0 0 0 1. The rest will be zeroed out. After here, will become 0 0 0. There will be 4 0, then 1, 3 zeros. And then 0 0 0, then 1 1 1 1, and then a 0. So therefore, this is the adjacency transposal. And once you'll begin to transpose, they are not symmetric, meaning that once you will begin to transform them, it will not be symmetry because, of course, due to the fact that they are not bidirectional. So thank you so much, everybody. I hope so that you were able to get for this operation. And next video, I'll begin to create also the adjacency matrix pertains to the, adjacency list pertains to the same type of graph. Thank you.